everybody. I am inside the bonus quiz for 1.2, and I wanted to get after this because these are some fundamentals, some core fundamentals that can really haunt you if you don't get off to the right start on them. And so you'll have to deal with this sort of situation a timeless number of times as we move through the course. And it's very easy to go astray here because in a sense this could be this situation, a negative 9 squared, or it certainly could be this situation, sort of like a negative 1 times a 9 squared. Now in this situation, the negative is part of the squaring process, it's within it, and we would get a positive 81. Over here, however, we have 9 squared, which is 81, and we're multiplying by a negative 1, which is a sign changer, and we would get a negative 81. Now, obviously, these are two completely opposite results. 81 and its inverse, negative 81. And so, which of these paths is the correct one? And it turns out it's actually this direction here. And so you have to get your mind around this and figure out a way of dealing with this as we go forward. Now I'm going to link to a video where I introduce what's called the white space hack. And the idea here is that in this situation, the parentheses are hugging the minus sign tightly to the 9, and there's no white space in between here. And so you end up with a positive 81. In this situation here, you could rewrite this with some white space. That is, you could type in a minus sign and then a bunch of spaces, or a tab, and then the 9, and then the superscript, the power of 2. And then you could go ahead and evaluate the 9 squared to get 81, and then you could close up that white space to get this. Now again, I'm going to link to a video at the end that fleshes this out in a little bit more detail. But the answer here is in fact a negative 81, and you need to find a way to deal with that. And in particular, I wanted to show you a situation that's going to arise innumerable times, and you don't want to trip up on this because it will make the preceding problem completely wrong. Let me show you this. This is an interesting situation here. It is right here. It's a substitution problem, and you're being asked to let x equal negative 1 in some expression. Now I've kept it simple here, but clearly this could have been in the third power or the fourth power. There could be more terms here, more variations on x. Anyway, you need to let x equal negative 1, and the question is, which one of these is the correct route, just like our problem in the bonus quiz. And it could be the situation in the bonus quiz, or it could be this case where the negative is closely hugged to the 1 and everything's being squared. And it turns out this is the correct route on this one here. And I just want to point out something, what I call practicing safe math. And the idea there is that whenever you substitute in a negative number, you put it in parentheses. And so there are no parentheses here, but when I substitute in, I put it in parentheses, and then I show the rest of the problem, in this case the square. And that really helps correct for errors. If you always substitute in negative numbers with parentheses, that would send you on this path as opposed to this path. And so you would get the correct answer of 1 here. So always practice safe math. When you sub in, always use a parentheses. So there's the answer for this one. Let's get on to problem 2. And this is an order of operations problem. And this one is particularly treacherous. And the reason is because your eyes are going to focus on this multiplication here. There's no space between the negative 7 and the 3. And there is space between these two. And so your mind is going to want to do this multiplication ahead of this division. And that would be the wrong path. Let me show you another situation here. This is the PERMDAS rule. Now normally it's PEMDAS, and I put this R in, and you'll see why in a second. It's essentially because there's this bilateral symmetry to the course that allows you to think about these things in a deeper way. And so it's a nice scaffolding for memorization and for building your thoughts around. In life you have light and dark, you have hate and war, you have love, excuse me, you have hate and love, you have war and peace. You have these natural dichotomies, these natural opposites, and it makes sense. You know, in algebra, we have addition and subtraction, and they're opposites of each other. They undo each other. And the same is true with multiplication and division. They're opposites and they undo each other. To have just an E here, as in PEMDAS, and not its opposite, roots, R for roots, is to really cheat the material. And in fact, exponentiation undoes roots, and roots undo an exponentiation. And we'll be undoing these in the second half of the course, using roots to undo exponents and exponents to undo roots. And so there is this bilateral symmetry. And one other point about that bilateral symmetry is that it's really not you know, it's not in this particular order. I could have reversed these and put the R in front of the E, so please really excuse instead of please excuse really. And the idea there is that subtraction does not precede addition, and addition does not precede subtraction. They're on the same level. And so since they're on the same level, they have the same power. And so what order you do them in depends on, as you read them from left to right, whichever comes first is the one you'll do first. And that's going to have importance in this problem where we have this division and this multiplication. As we go left to right, the division appears before the multiplication, and so we'll do this division first. One more thing about the course in general, and that is this idea, this scaffolding, this infrastructure. If you go on in math, you're going to have, you know, this course is pointed at getting you ready for calculus, and there's two new operations, differentiation and integration, and they undo each other, just like these two do, and these two do, and these two do. And if you stick with the course and we look deeper into it, as we move on, we're going to have the opposites of ordered pairs. The opposite of the point 1 comma 2 is 2 comma 1. And even another idea here that we're going to be dealing with. This is functional notation, and we're going to find the inverse of a function. That's what this -1 here, it's not an exponent in this case, it's saying this is the inverse function of this function. And notice x is being multiplied by 3 and then having 5 subtracted from it. Here we're having x is having 5 added to it. Instead of multiplication, we're dividing by 3. And you'll see that this is the inverse of this. So this bilateral symmetry has huge play in the course as we go forward. Now let me get at solving this thing here. And my first move is to rewrite, and I'm going to do this exponentiation here. -2 times -2 is +4, so I have a -4. And then I'm going to go ahead and just copy. But as I copy, I'm going to be creating some white space between the operations and the operands. So notice the white space here, and then here's the multiplication, and notice the white space here. And that's to really disengage my eye from being seduced by this multiplication, this close multiplication here. Now I know these are on the same level, and this comes first. So my second line is a bit narrower and looks like this. And I'll go ahead and do this here. 49 divided by -7 is -7. So I have an addition of -7, which is the same as a subtraction of 7. And then I have this multiplication by 3. And obviously this has got precedence. So we'll go ahead and do that. And it's true I could do more work, but I'm just taking it one step at a time here. That's the result of that multiplication. And now I'll do this subtraction. And all that's left is to finish it. And notice the form that I've got here. I call this a funnel. And you know, the problem gradually narrows until we get to the answer. And I say gradually because you don't want to be an answer jumper. You don't want to try to go from here to here. You might be able to get away with it, especially with a lot of practice, but for now, go ahead and stretch it out and take your time going from step to step to the bottom of the funnel where the answer pops out. So the answer to this one is 9, and let me click MathXL Live and go ahead and put that in there. And I'll ask it to submit, and we'll see what I get here. I got the first question correct, and I got the second question correct. So 100%. And I hope this helped. I'm going to put the link in now for that video on YouTube for the white space hack, and get after the next bonus quiz.